Hi, I'm David. Intake air temperature, or IAT sensors, are essential to help the modern motor vehicle comply to strict emission regulations. They can have different types of faults, resulting in various diagnostic trouble codes. In this module, we'll look at a P0112 or a P0110 symptom byte 03. Both these are sensor low voltage codes. The IAT sensor is a passive sensor in which resistance changes with temperature. The electrical resistance decreases as the temperature increases, and vice versa. The varying resistance affects the voltage drop across the sensor terminals and provides electrical signals to the engine control module, or ECM, corresponding to the air temperature. The ECM uses the air temperature information as a correction factor for fuel, spark and mass airflow. The normal voltage drop range for the IAT sensor on this vehicle is 0.2 to 4.6 volts. If the voltage goes below this range, then a P0112 or a P0110-03 sensor voltage low will set. From this table of faults, it can be seen that the cause of a P0112 is a short to ground on the signal wire. This can occur in the signal wire itself, the sensor, or the module. When dealing with temperature sensors, there's a tip you can use if you've got a scan tool and the vehicle's been standing overnight or for an extended period of time. With the ignition on and the scan tool plugged in, I'll compare the readings of the coolant temperature sensor and the intake air temperature sensor. They should be within a couple of degrees of each other. This will help decide if one of the sensors is not reading accurately. The intake air temperature is at 135 degrees Celsius or 275 degrees Fahrenheit, and the coolant temperature sensor is at 22 degrees Celsius or 72 degrees Fahrenheit. This indicates a problem in the IAT sensor or circuit. If the sensors were measuring close to the same temperature, this would indicate that the module is receiving the correct information. If the readings were like this on a cold engine, then it indicates a fault. A DTC will not usually set under these circumstances because the IAT sensor is still within its voltage limits. The customer, however, may be complaining about poor performance or excess fuel consumption. Referring to the schematic, it can be seen that the IAT sensor is part of the mass airflow sensor. The IAT sensor has a ground connection shared with a mass airflow sensor on one side and is connected to the ECM on the other. There will be a pull-up resistor inside the ECM which will be connected to a 5-volt reference. Some systems can have a dedicated low reference connection back to the ECM, and others can have a low reference supplied by a vehicle ground, as seen here. To start the diagnosis, it's necessary to disconnect the mass airflow sensor. I can now check for the ground connection. The best way to do this is use a multimeter set on voltage. It's a good idea to set the range to 2 decimal places. This will allow the meter to read quicker and prevents any misleading readings in millivolts. You'll need to know the battery voltage, so make this measurement first. Now I'll check the voltage between the connector ground pin and battery positive. Now I should get pretty close to battery voltage. If there is no voltage reading, this would be an open circuit. A very low reading would indicate excess resistance. My reading is within specifications, so I can move to the other IAT connector terminal. With the ignition on, I'll be looking for 5 volts between the connector and battery negative. I have no reading. If there was 5 volts and a ground, the fault must be in the sensor. An easy way to confirm this is to look at the scan tool data with the sensor disconnected. If the reading is now minus 40 degrees, then the wiring must be okay and the fault is in the sensor. If there isn't 5 volts on the signal wire, you'd next check for a short to ground. The simplest way is to leave the multimeter connected to the sensor signal wire and move the other lead from battery negative to battery positive. If there's battery voltage here, then there's a short to ground. This could be located in the harness or the module. Turn the ignition off, disconnect the ECM, and check your reading again. If the ground is still there, then the signal wire must be short to ground. Looking at the schematic, there is no connector between the mass airflow sensor and the ECM. This means there's no other point to disconnect to help in the diagnosis. If the short to ground is now gone, the signal wire is shorted to another circuit from the ECM or a short to ground in the ECM itself. One way to check the harness is to connect one probe of the multimeter to the signal wire at the sensor and see if you have a connection to any pin other than the signal wire pin at the ECM. If you have access to a circuit tracer, then it will be much easier. Simply connect the tone generator to the signal wire and see if the probe can pick up the tone on any other wire. If either of these methods doesn't produce a result, then the fault must be in the module. So that's the diagnosis of an intake air temperature sensor low voltage. As you can see, the procedure is not difficult if you follow a systematic approach. Always work on one part of the circuit at a time. Diagnose, don't guess. And remember, training is the key to your success. Bye for now.